Hey everybody, welcome to part 3 of our coffee coaster project. I'm Jake here at Langmuir Systems, and basically, if you haven't seen the first two videos, basically what we did in the first two is we figured out what our part is going to look like, we designed it up in CAD, and we figured out how we want to design this so it can be easily machined. In the second part, we drew up our first half of our cam, and we got our program figured out, and we actually ran it out on the machine, and we cut off the back side of our part. Now, we're on to part 3 and the front side. So basically what we want to start with on the front side is we want to figure out how this is going to be sitting in the machine, and we need to set up our stock accordingly. So the first thing I've done here is I've set our stock up basically so that it's the same stock as the last side of our operation. So you'll notice if I click on this back side here, everything's the same except for our coordinate position. So if I click on our front side face again, basically these little bubbles just bounce back and forth between which operation you're doing, or which setup you're doing. And so I'll click on this bubble, and you'll notice my origin has moved. Now, we talked about this a little bit in part 2, but basically when we pick our origin, we can come over here. This is our work coordinate system, our origin system. And basically what we've done is we've clicked on this stock point. So if you click on this stock point option, you can see all these little bubbles pop up. And these are all the different options, all the different places where you can actually place your stock origin. Now basically we want to do this kind of like what we did in the last video. So what we're going to do, we know that we're going to be touching off on our left side. Our Y is going to be on the same solid jaw. So that way we get a nice square part. And our Z is just going to be the top of our stock. So I've gone and I've just basically traced the lines that I know I'm going to be touching off on. So the left side of the part, the solid jaw side, and our Z, of course, is pointing up. So that leads me to this bubble. Now I could click on other bubbles to move it around, but I know I'm going to choose this one. And this is over here in our stock point option. Basically, there's a couple other options you can look at. You can pick model boxes, you can pick origin models, but we know we're going to be touching off our stock, which is why I've decided to go with stock point option. I'm sure we'll explore later other options in further videos, and we can take a look at that later, but for now, this is just the easiest what we're going to go with. And just to show again, in our mode, from previous setup is our stock option. So that keeps everything nice and simple. So now the first thing we need to do, if you'll remember correctly, is we left a bunch of material for our part to hold on to, in our jaws in the last operation. So now we need to chop all of that material off. So what we're going to do is we're going to do another facing operation pretty much just like the front side. Except this one's going to have a little bit of a twist because we're not cutting off 45 thousandths anymore. Now we're cutting off 195 thousandths. Now how did I get that number? Basically, what I had to do is I had to take a look at the part. I had to see how much material we have left to take off, because I know I want this part to be 375 thickness or 3/8 thickness. And so what I had to do is I had to measure how much material I've taken off and how much material I have left, and then subtract 375 from that. So let's take a look at the measuring process and how I came up with those numbers. So here we have our part after our first operation where we zipped around the outside and put our pockets in. And what we need to do here is we need to measure the total width of this part. That way we can subtract our 375 from it and figure out our depth of cut. So in the first measurement, I'm getting around 570. But as we all know, the stock's not going to be perfectly thick. So what I'm going to do is I'm going to take multiple measurements around the outside and average all of the thicknesses I get from that. So this next one is going to be 567. And so after about all these measurements, it comes out to about 570 for our total thickness. Now, as I'm measuring with these calipers, just in case not everyone knows exactly what I'm doing here, I'll kind of explain how I'm holding my calipers here a little bit. What I'm trying to do there on the back side is use that little space in the calipers to avoid the burr on the back side. Another thing I'm trying to do is I'm trying to avoid any burrs that might be in these circular pockets. So what I'm doing is I'm holding my jaws just under those pockets. And again, I'm using that space in the back of the calipers to avoid any burrs that might be on my stock material. And I'm getting it nice and snug down in there until I get a good solid reading. So now we have some numbers to start working with for our MRR process. Basically, we know our depth of cut is going to be 0.195, and we know our MRR we're shooting for is going to be 3 still, because we want to make the most out of our machine. Now we need to figure out width of cut. Width of cut, we're going to basically take as much as we can. We want to make sure this is a quick process, so we're going to take 0.356 just to get the most out of our tool and the most out of our machine. And last of all, that leaves us with our feed. Now we have all the other information, and so using all of these other numbers, we can find our feed rate. Now I say we want to make the most out of our machine, so we are shooting for 3 mmR, but this is just because this is how I like to machine. I like to kind of push things a little bit and make sure that I'm getting the most out of my tool and that we're going as quick as possible. But you know what? If you're not comfortable with 3, then you can go ahead and bump it down to 2. There's nothing wrong with taking things a little slow, especially if we're just kind of like casual machining, if you want to think about it that way. So 3, 2, 1.5, 1, doesn't matter. If you want to bump these numbers, play around with them a little bit, do what's best for you and do what you like to do. So we have our MMR, we have all of our numbers set for our parameters. Let's actually take a look about putting them into our operation. So I'm just double clicking here on our face to bring up our options. I'm sure you've noticed, but I've already gone ahead and put these in, and we're just going to kind of walk our way back through them and I'll explain. So over here we have our same spindle speed. It's pretty much going to be 8,000 for all of our end milling operations that we're doing. And our cutting feed rate, I have 43 inches a minute to hit that 3 mmR. Feed per tooth will automatically Fusion does the math for us, which is great. And lead-in, we like to keep around the same as cutting. Lead-in's not going to be as important as our cutting feed rate, so I just kind of keep it around 43. So I just put in 50, 50 for lead out, 50 ramp, and 50 plunge. And then this feed per revolution is also going to be automatically updated by Fusion, so we don't have to worry about that. For our geometry, this is the same face operation as our front side. So basically what I've done is I've told Fusion from the stock selections that we just want to take the stock and go down to the top of our part. And Fusion's smart enough to realize this. And so it goes, okay, I see your stock and I see your top of your part, I'll just take that off. Great. With the heights, I'll just make sure that my top height is set to, my bottom height is set to my model top. That way I know, and I can take a quick look, that everything's going to go just a little faster. Things aren't going to go way out of their way to retract, and so that's what we're looking for there. The rest of these, feed height, retract height, clearance height, those are all pretty important, and Fusion sets those automatically just to make sure it clears everything. Nothing's going to crash, so I leave all those. Those are all fine. This is kind of important here. We have our step over. Our step over is actually our width of cut. So whenever I say width of cut, or whenever I say 356, this is where I am putting this number into. And so I've typed in 356 for my step over, my width of cut amount. Pass extension is covered automatically. This is just as the tool comes across, it'll go a little farther just to make sure it cleans up before it comes looping back around to come across again. And this is automatically set in by Fusion, so I don't argue with Fusion there, that's fine. And the other thing I leave here, stock to leave, another 5,000s, just so that way when we come in with our finishing face cut, we have a little material to clean up with, and it'll make it look real nice. Linking, everything here is pretty much just automatically set, good to go. So that is our roughing operation. Just like our front side, it's going to come through, it's going to kind of buzz through all this material. See how thick that is? That's way more material. That's a far cry from the 45 thou we were doing. This is why we're just we're talking through this again, redoing our MMR just to make sure we are playing it safe and making sure we're doing the right thing. There's that 3-5-6 step over. You can see it almost takes the whole width of the tool. We're getting a lot out of this tool. Now, one thing we've done, I should say, before ahead of time, is we've actually gone through and we've taken a test cut on this part. And from just a stock piece of aluminum, just to make sure that when we're gripping on this, it's not going to come flying out of the vise. And so that's not a bad idea. It's a good kind of friendly tip. If you're never sure about the cut you can do, or if it's too much, go ahead and just, if you have some stock material laying around, throw it in the vise. You can manually jog your machine down and touch off and just kind of jog it into the type of cut you're going to be doing. So I touched off on the front here and my top, and I moved it over 3-5-6, my width of cut, down 1-9-5, my depth, and I just ran it across at my feed rate, just to make sure that, we can do this, and we're not going to throw anything. And so that's always a good idea if you're not quite sure if you want to be extra safe. And so that's our roughing finish, or our roughing face operation. And then we have our roughing finish, which is going to be pretty similar, same 8,000 RPM. It's using the same geometry as the previous operation. Cutting feed rate is going to be 50. Lead in, lead out, all of this is going to be 20. I'd say 50 for a finish is pretty good for our facing operation. Gives you that good feed rate. We got a good feed rate on our other half of our part, and so I'm pretty happy with these numbers. For heights, we set our model top, and I can just double check. Yep, that's good. Always helps to double check. No stock to leave because we're cutting right down to our dimension. Our step over amount is going to be a little smaller here, just because it's a finish. And finish can be, the step over can be a little closer together. That way you don't get quite as many lines, and you get a little bit more coverage with your tool, so it'll take a little longer, but you know what? We want the finish operation to make the part look nice. It doesn't have to be super fast. We're not out on the industry floor. We're not having a boss looking over our shoulder trying to crack us down to get the most parts done. No, we are our own boss. We can make it as pretty as we want to and take as much time as we want to. Okay. So that is our finishing operation. Now what we're going to do is we're going to jump over to our machining side, and we're actually going to see how this gets loaded into, and we're going to see how this runs on our machine. And we'll explain a little bit more when we get there. So I'll see you out on the machine. Alright, welcome back to Fusion. Now that we've faced off the top of our part and we have all of our stock removed, what we have left basically is our outside profile, and our thickness is exactly where we want it to be. That means the only stock we are going to have left on this part is going to be these inside pockets. So now what we can do, now that we've done all that, is we can move our origin point down to be on our exact machine surfaces. See, from before, we had to have our origin point way out here because we still had stock to remove. And now that we've done that, we can make a new origin point that's actually touching the outside of our part now that we have a good clean machine surface. And that's going to be important because it's going to help us with our accuracy, and that's going to help us maintain our positions a lot better. So what I've done here, I'm just going to double click on this new setup here. And if you're curious, over here in the setups, you can right click and you can click again to create new setup. That's how I create these new setups for when we're flipping or when we're this setup is just for accuracy, not flipping, but for when we want to make a new setup and do new touch-offs. So I'm going to double click, and right here, what I've done is I've come up to my stock tab, and for our stock, what I've done is made a fixed size box. And this is going to be like centered in our model. And from that, I basically just typed in, our finished dimensions, 4.5 wide by 4.5 tall and 375 thick. And so that is our finished part. Now you'll notice there's some ghost stock around the edges. That's not actually going to be on there when our part is sitting in the machine, but Fusion doesn't know that. What it's looking at right now is it's looking at this point I've told it here. So it's going to automatically fill this in, but just keep in mind that's not really there. And so this origin point here is selected by coming down here to our model point. Just in case it's not where we want it, we can actually click on this box point and we can give it the exact position we want it to be in. And make sure our Y and our X and our Z are still facing the right directions. And that's our new origin point for the setup. So now we actually want to go out onto the machine and we want to use an edge finder to retouch off our part and to make sure we have this really zeroed in. So let's jump back over to the machine and I'll show you guys how to use an edge finder to make a new origin point on our part. Alright, so we just got done mowing off the top of our part. Took off nearly 200 thou there, and so now we're left with a nice clean finish, good looking lines, everything looks good. So the next thing we got to do now is we got to touch off our part again. See, what we did is we touched off our stock earlier, and as we know, stock's not perfect material, it has some slight bends and variations to it. So if we want all of our features on this side to match up with our features on the back side, what we're going to have to do is we're going to have to touch off our part again, now the finished part of our part again, just to really dial things in. And we don't want to screw up our sides of our part with an end mill, so what we're going to do is we're going to use an edge finder. Now if you look up, I've already got one loaded into the spindle here. There's our edge finder. And what an edge finder is, it's basically a blunt tool that has a slight wobble at the head. So as you start to spin around, that head of this edge finder is about 200 thou, and it comes down to your part, and you start to touch the part with this edge finder, and this wobble will become less and less and less, until finally, once you get at the edge, a little past, it'll shift to the side very quickly. And that's when you know, oh, I've just gone past the edge of my part. So then you back it off, maybe a thou or two, until it's back to rotating almost perfectly. You raise it up, and then just like with the end mill, we come over half our tool diameter, which in the edge finder would be about 100 thou, and then we set our X0, our Y0. We can zero our part without having to cut into it. And so edge finder is really nice, a nice manual way to touch off, especially if you don't have a probing system set up. MR-1 is going to have a probing system available for it, so if you don't want to do it the old-fashioned way, if you want to probe, that's great, but if you like edge finders, if you have a lot handy, this is a great way to touch off your part without actually having to cut into it. So, let me grab my controller quick and we'll get going. Okay, so before I start this up, one thing to keep in mind with edge finders is they have a range of RPMs that you can spin them at. I like to spin mine around 1000 RPM, 1200 RPM, just to kind of keep it in a safe limit, because if you exceed the listed limit on an edge finder, that wobbling tip at the end can actually break. It can become warped, and you might break your edge finder if you spin it too fast. So always double check that you're spinning at a good RPM, a slower RPM when you're running your edge finder. And so now I'm going to fire this up, and we're going to touch off our sides of our part and set a new X and Y. And it's a good idea to kind of lightly deburr the side of your part, just to make sure you're not going to be edge finding on a burr when you go across. So if you see, it's not really wobbling too much, so what I'm going to do is I'm going to help it out a little bit. I'm just going to flick it. There we go. Kind of flick it a little bit, gets the edge of it wobbling. You can really see it going now. So we're going to start to bring it in. Always be careful when you're reaching in a machine, by the way. Make sure you're not going to get caught on anything. Make sure you have short sleeves. It can be very dangerous reaching into an open machine, so always be careful. See that? See how the wobble's gone down a lot? I'm going to start stepping it in. I was just stepping it at 10 thou increments. Now I'm down to 1 thou increments. So we're going to start stepping it until that. Now it might not pick it up on camera very well, but that is what you're looking out for. Now it takes some practice. Certainly edge finding takes some practice to get used to, but you'll know when the edge finder snaps off. And you can back it up a little bit, get some more practice in there, see it start to wobble again. I'm going to bring it back until I see that wobble disappear. It's gone. And I'll step it over until I see it stop. So now I'm going to back it off, maybe 2 thou. I'm going to raise it up. There's our wobble again. So now I know that was a tip of our edge finder here was 200 thou. So I need to come over 100 thousandths, and that's going to be my 0. Or I can just type in negative 100 thousandths, and it knows. So I'm going to do Y negative 100 thou. Now we're going to zip on over and do the same thing for X. Excuse me, that was X that we were just touching off there. Now we're going to set Y. So what we did is we just typed in X negative 100. Now we're going to do our Y. And we're getting a little close to the jaws here, so we're going to be a little careful coming down. So I'm going to slowly step her down. Okay, that's looking good. Now I'll bring it back. Ten thou at a time. Now 1 thou at a time until we see the edge break. Right there. So now back it off a little bit. Bring her up. And the same, we are in our Y. So now I'm going to type in Y, and we are above the part. So we need to tell the machine that we are Y 100 above it. 0.1, okay. And there you go. We've now touched off our part without having to use an end mill, without having to actually cut into anything. And so edge finder is very useful if you don't have a probe, or if you feel like being old-fashioned. So now that we have our new X and Y, we're going to put our end mill back in. We're going to touch off our Z. And now, when we machine this side, it should be pretty darn close, pretty much near perfect to our other side of our part, and it's going to look real nice. So I'll catch up with you then. And we're back with our part now perfectly situated in our vise and perfectly touched off, so now we know exactly where it is. Now we can get to the fun part of hogging out a whole bunch of material. What we're going to jump to now is we're going to jump to our pockets. So the first thing we're starting off with here is an adaptive clearing. And what this adaptive clearing is going to do is it's going to come through and it's going to mill out our circular pocket and then step up to do our square pocket. So let's dive into what all goes into doing an adaptive clear. Now, adaptive clearing fusion is going to take basically the best route. So we kind of give it a geometry, we give it our parameters to follow, and fusion is going to come up with the tool path to clear all this out as fast as possible. So for this adaptive clear, we're going to bust out our old MMR chart again, and we're going to try to figure out, I've already filled this in, so I'm a little ahead here, but what we want all of our feed rates to be, and we want to try and figure out how fast we want to run things here and keep it within our 3 MMR. And we also know that our depth of cut is 1/4 inch from the top of our part here down to the bottom of our pocket. That's going to be the biggest chunk of material we're going to be taking out at a time. And so let's make our width of cut, say, 150 thou, and that gives us a feed rate of about 80 inches a minute. So we have our same spindle speed of 8,000. We have our cutting feed rate of 80 inches a minute. Lead in feed, lead out feed, I like to cap those out around 50. Same thing for ramp and for plunge. So for our geometry, we basically just told it, hey, you know what? You know our stock, you know what needs to be cleared from top to bottom, and Fusion goes, okay, I sure do. And so it's going to basically take out any material that's not stock here, unless we tell it to leave some, which we are going to tell it to leave some here in a second. So we've got our heights. I've double checked that the top height here matches the top of our part. So our retract is not going to go too far. It's going to make it program a little faster. If you want to change that, you can just do top height, model top. For our passes, we've typed in our optimal load, which is our width of cut here at 150 thousandths. We are machining the cavities. Directions usually climb. You always get climb for a better finish, better all-around machining experience. But the big thing here is we've done stock to leave. Now, this adaptive clearing is going to be our roughing pass. And so we're going to leave 5 thousandths on the walls and 5 thousandths on the floors. And we're doing a roughing pass for this adaptive clearing, so that way we're going to be chunking out a lot of material, and it might not look like it, but that tool is going to flex a little bit. And since it's roughing, it's definitely going to be a rougher finish as this goes around. And this is going to be a pretty cosmetic part, so we want it to look really nice. And so we're going to have it rough and hog as fast as it can, but it's just going to leave a little bit of material. That way when we come around with our finish passes, those finish passes are going to take that flex out of our tool, and it's going to clean up the edges very nice to leave a nice clean finish. So we're leaving 5 on the walls and 5 on the floors for our finish pass. For our linking, everything is the same here. The only thing that we have changed here is if we come down to a ramp type. Our ramp type is a helix, because what this adaptive clear is going to do is it's not going to just come in with the end mill and plunge it straight into our part. It's going to do the spiraling helix down into it. And that's going to be a lot easier on the tool, and it's going to make things go a lot faster. And the thing we've done is we've changed the ramp angle. It was a 1 degree, so that means it would be a very tight helix, and it would take a while. Our machine and our tool can handle it, so we bumped it up to 4. So it's going to come helixing down at a steeper angle. And so that is our adaptive clear. So you can notice our tool paths here. There's our helix coming down in, and then it's just going to spiral out and finish the rest of that. I'll come back and I'll do a simulate just so we can kind of see more what's going on. After our adaptive clear, we come into our 2D pocket. This is our finish operation. And basically what we've done is we've just kind of filled in our finishing parameters here, which has our cutting feed rate at 20 inches a minute. We're not really worrying about MMR so much here because these are just finishing cuts. These are very light. MMR is for when we're trying to take the most material as fast as possible, and we're channeling our inner like maximum efficiency machinist mode. Not now. Now we're going for aesthetics. So we're just going to bump everything down to 20 inches a minute. We've told it our pocket selection over here. We have our contour mode and selected pockets. We've told it that we want this circular pocket cut out. Same thing for heights. Double check that it's the top. Passes. We've turned on a finishing pass here. So what it's going to do is it's going to come down, it's going to mill out this pocket, and it would come around the outside, and ordinarily it would just be done and pop up. But we've told it to do a finish pass. So what it'll do is it'll spiral down and out. It'll get around to the outside, and then it's just going to go around one more time, just to make sure that all of our finish is consistent and that we are getting, our complete beauty pass, basically. And so we've turned off stock to leave. We want it to come down to our dimensions we've told it. And for linking, everything's just the same. We've done a ramp type plunge because there's no material there, so it can just come straight down and begin. And then after that, we have our second 2D pocket. Let's double click into this. It has a little bit of a faster feed rate at 50 inches a minute. The rest are 20 for our ramping and our plunge, and lead in, lead out's 50. Our geometry. Now what we've done here is rather than selecting this edge as our geometry, because then it would come down and it would try to basically finish all this empty space. And that's just wasted time. We don't want that. And so what we've done is we've selected a pocket. And so rather than clicking on the edge here of our part, we're going to click on the face of our part. And Fusion is smart enough to know, oh, they only want this face. We can just ignore all this empty space. So that saves us minutes of machine time. And let's say we wanted to mass produce these coasters for fun, that minutes for every part adds up to hours. And so that saves a lot of time, a lot of money. And we'll check our heights. Heights are good. Check our passes. We're also going to do a finishing pass. So it'll clean up everything and then go around one extra time to make sure those walls are nice and clean. And we've turned off stock to leave. And as usual, linking, the only thing we've changed is plunge. So that is our other pocket. So let's do a quick simulate of what that's going to look like here, just so we can kind of make sure everything's running smoothly and to make sure that we have these ideas kind of a little bit more concrete in our minds. Wow, that was fast. Okay, let's back that up a little bit. There we go. So you can see it kind of spiral down in there and it'll start to make its way out. Look at that's a 1/4 inch material right there, and that's normally a pretty big bite for aluminum, but we've worked it through our MMR, where we're taking 150 thou on the sidewalls, and only at 80 inches compared to like 100 what we were doing earlier. So we know it can handle it. It's just a little different way of doing it. And like machining, there's always a million different ways to achieve the same results. And everyone will come up with something that they can do their own way. And so let's keep going here. It's going to chunk out all that bottom, and then when it gets to the outside, it's going to come up and it's going to do the top. And it'll jump from one corner to the next, cleaning up those outsides, but leaving our 5 thou on the walls and our 5 thou on the floors. And then we're going to come into our finish. This one just plunged straight down, and now it's just going to spiral out, cleaning up the floors and cleaning up the walls like we told it to. See, it's going to get to the outside here, and then it's going to, then it did that. Well, it did the finish pass. Trust me, it was there. That's why the wall's blue. But it got to the outside, and then it did a little extra pass. And now it's going to do the same thing, jumping over our empty pocket, because Fusion is smart. It knows to avoid that. It's going to save us a lot of time, a lot of effort. And there's that little extra, a little sneak peek there of what we're going to be talking about next, after we show some footage of hogging out all this material and clearing out our pockets. Okay, if you were paying attention, you saw that little sneak peek we got earlier. What we're going to do now is we're going to do our chamfer and also our engraving. Now, a chamfer tool is going to be a tool change, so it's going to be in a different program from our earlier programs here, like this front side facing. That was on a different origin point, so that's going to be, these two operations will be one program. And then we did our new origin point, so then the adaptive and the pockets are going to be in a program. And then our last one is going to be this chamfer and the trace, which are going to be in our last one. So what we've done with this chamfer, very similar to our backside, is we have our chamfer tool, our 1/4 inch 90-degree chamfer tool in here. Its feed rate is going to be 20 inches a minute. Lead in and out is going to be 50, and ramp is going to be 50. We're not really doing any ramping, so we'll just leave it at 50. And what this is going to do is it's going to come down and just give us a nice chamfer around the outside of our part here. And we're doing it at 20, so it gets a good finish. Our geometry, we've just kind of picked our edges, the top of our edges, so that way it knows what to chamfer here. We check our heights, model top's good. Our passes, the thing I've done here is I've done a chamfer tip offset of 70 thou. And what that is going to do, real quick, I'll finish at linking. Linking is all just the same. What this 70 thou tip offset is going to do is it's going to bring the tip down a little ways past the part, so that way it's using kind of the middle of our tool. And let me just right click and do simulate here just to kind of see what I'm talking about. And I'm just going to drag the timeline ahead to right about to here. If I move the camera, this is what I'm talking about. So if we didn't have tip offset on, what it would be doing is this very tip would be at the end of our chamfer here. And that's fine, but we've got a lot of tool here. We've got a lot to use, and if our tip isn't perfectly intact, if it's not a perfect new tool, then it could leave just the tiniest bit of an edge as it goes along. So what we've done with that 70 thou offset is now it's going to be using this whole tool, and there's going to be zero chance of it, unless your tool is super gnarly, it's going to have a zero chance to leave a little edge. And so we can watch that go around real quick. Since we're here, since we're in simulate, what it's going to do is it's going to zip around the outsides, and if you'll notice, our retract point is on a radius. So that way when the tool leads in and leads out, the little mark, there's like a little line that the tool leaves, because it's not perfect, when it leads in and out, that little mark is going to be very much reduced if it's leading in on a radius. And so you can actually pick, let me just detour a little bit into our linking. This is a position, so we can pick our entry position. So what I've done is I've just selected entry position, and I've just picked on a radius. And wherever I pick here, that's where it's going to come in at. So we'll go back to simulate. I'm just going to drag it across, and there it comes in and out right where I told it to. Next, it's going to just kind of jaunt over to the inside. And what the nice thing about simulate is we can zoom in, and we can make sure so that that's going to be kind of a tight squeeze for that chamfer tool. We can make sure that it's not going to hit our inside edge here that we want to keep sharp. So we can watch the rest of it go, make sure it's the size we want, and that looks good to me. That's going to make a good part. Let's just close out of that. Next, we're on to our trace function. Now I like to use trace for text, especially for the text we like to use. We use if you remember our first video where we talked about our sketch, and we used our text sketch that we did, we used Montserrat for our text, our font, basically. And that makes a nice big blocky letters that are really easy to trace. Plus it looks good. That's also a nice bonus. And so what we've done in our trace feature here, if we right click it, these are our pretty good feeds and speeds for what we found out to do text engraving. So we have a cutting feed rate of 5 inches a minute. You'll also notice for our tool, and on the last chamfer as well, that we've selected our 1/4 inch 90-degree spot tool, which is just in our big tool library here. So if you click on tool library, you can do a tutorial inch or sample tools inch. Those will have kind of a big library of tools you can pick from. And what we've done is we've just selected a 1/4 inch 90-degree spot drill That's the closest thing to what we put into our machine. All the heights are the same, all the diameters are the same, and so it basically functions exactly the same except just a different name. And then we have our 3/8 flat end mill from earlier. So we will select our correct tool. We have 5 inches a minute for feed, lead in and out are 7. Ramping is just coming straight down, so it's 20, and plunge 7, retract 7. Pretty simple, but that's the 5 is the important thing here, and that's going to give us our good finish as this goes along. And for our geometry here, we've selected basically our chains is what it calls it. So if I get rid of this here, what I can do is I can hover over my sketch and it'll highlight one part of the text. And I can just go from one to the next, selecting my chains, and that's how it knows what to cut out. We have our model top set to 50 thousandths above, and what that is going to do, that's our feed height. So that's basically telling them, so this is a little different from the other ones. Oh, there's Cameron. And what it's going to do is it's going to come and start feeding at this 50 thousandths rather than from 200 thou high. And so our tool is going to come down quickly and then slow down when it hits this green line. So we've brought this green line down a little further so that way it's going to rapid more and it's going to make for shorter run times, which is what we want to see. And the last thing we're looking at here is going to be our passes. Everything's pretty much the same except for this axial offset. This is how we tell the tool just how far down it's going to be going. We've given it 6 thou down, which we found after some testing to be a good depth for our tool. And linking is all going to be pretty much the same. So we're going to give that a quick simulate just to make sure it's going to do what we want it to do. So we can just watch it dance across the text, basically. We can pause, zoom in, and you actually see the notch. Ooh, it gets a little funky. You can see the notch it's going to be taking. And to make sure it picks up. I've had that happen before where it's supposed to pick up, come over, come down, go across. I've had it happen where it did not pick up. It just pretty much carved a line from one, not on this part, but it carved a line from one corner to the next, did everything, got to the end, carved another line, wait over to the next. It worked, but it wasn't very pretty. It had some scars on it. So this one is picking up how we want it to. It's writing very quickly how we want it to. And it's going to make it look really good, add a nice little personal touch to our part at the end. So there we go. Now we just basically post our lines of code here, and then we put it out on the machine. And now if you haven't seen any posting, I can give you kind of a brief example of what that's going to look like. We come up here to our NC program button and click it. So this is the posting screen here. And this first one is where you can tell Fusion what kind of post you want it to use, because a lot of people will be using custom posts to get exactly what they want. This is our custom post here at Langmuir. We'll have this available for people to use. We can next do our file name to here and our file number. The number is the computer is going to put into the code, and the file name is pretty much what the file is going to be called, so that way you can remember it. For this, we can just fill in 1001 is fine for the number, and we'll just say example code. Our output folder is basically what file in your computer that you want this to be saved to. All this stuff I kind of leave as it is, built in. I just make sure this is in inches, that's good. The main thing I'm concerned about is the operations. I want to post, let's say, my chamfer and my trace. And so what I'm going to do is I'm going to make sure everything else is off. And I'm going to click my chamfer and my trace. That way when it does post this code, nothing else is going to be posted, just these two operations. And then I'll hit post. And it gets successfully posted to that folder in there, and so that's where I can go to retrieve my program. So all of my programs are ready to go. This chamfer just got posted, so let's go see it in action on the machine. Here we go. At the end of all our hard work, this is the product we got. And I think it turned out pretty well. Pretty happy with the finishes we got. We got some pretty cool swirl pattern going on and a nice rectangular pocket pattern and all kind of blending in with each other. I think the chamfers turned out pretty good, and so I'm happy with it. You know, we got our 4 square circle pockets back here to put our feet into. So here it is with the feet on in there. These 4 are going to help it so that way it doesn't slide around, doesn't scratch up our surface too much. These are just 4 easy pieces that I got from McMaster-Carr, pretty cheap, and fits my mug really well. I can slide it around and it doesn't go anywhere. The feet hold it securely in place even if I give it a pretty good push there, so I'm pretty happy with the project. If you guys like this video, please feel free to leave a thumbs up or comment down below. If you want to see more videos like this one, feel free to subscribe to our channel. We'd love to have you. And we're looking forward to the next video in our series that we're going to use some steel and we're going to make some a little more complicated parts, get a little deep further down into MR-1. Can't wait to see you.